Hi, this is Mr. Frank, and today's lesson is going to be about finding linear regressions as well as correlation coefficients using the DESMOS graphing calculator. I'm going to use question number 35 from the June 2022 Regents exam. An insurance agent is looking at records to determine if there is a relationship between a driver's age and percentage of accidents caused by speeding. The table below shows his data. I could see a table where age are the X values, or my L1, and the percentage of accidents caused by speeding is going to be the Y data, or my L2. State the linear regression equation that models the relationship between the driver's age, X, and the percentage of accidents caused by speeding, Y. Round all values to the nearest hundredth. Okay. So the very first thing I'm going to do when I'm doing a linear regression is try to get all of this data into the graphing calculator. All right, so that's step one. So I'm going to move over to my DESMOS calculator, and I'm going to just hit this plus button on the upper left here, and I'm going to add a table. And I can see automatically it assigned my X values as my X1s, my first list, and my Y values as my Y1s. All right, let's see if I could kind of get this half screen and move this over here so I could see the numbers as I type them in. So there are my values of X. So I'm just going to click into my X value, and I'm going to get all my X values. So 17, I'm going to hit enter after each one. 18, 21, 25, 30, 35, 40, 45, 50, 55, 60, and 65. All right, great. I got my L1s all in there, or my X values. So I'm going to go back up, and I'm going to click in right next to that 17. I'm just going to put all of my Y values in, making sure that they all correspond to the correct number above. So 17 has 49, enter. 49, enter. Oh, I'm going to hit the enter button. Every time I hit the enter button, it automatically goes down one. 38, enter. 31, enter. 33, enter. 24, enter. 25, enter. 16, enter. 10, enter. 5, enter. 6, enter. Now, one thing I like to do when I'm entering a table of values is to make sure that I did the numbers correctly, that they were entered correctly. So one of the things I do is I count how many columns there are: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I come over to my table, make sure I got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So far, so good. Then I kind of randomly choose one. 40 corresponds with 24, 40, 24. All right, I think I did a good job, and I'm ready to find my linear regression. So I'm just going to open up my calculator here. And once I have that table in, I'm going to click into the second input area underneath my 1, right down there. And I'm just going to type in an equation of a line, the basic slope-intercept form, which is y equals mx plus b. However, when we are doing a linear regression, it's not exactly equal to mx plus b. It's approximately. We're finding the best line of fit. So I'm going to use the little squiggly tilde kind of line on the top left of my keyboard instead of the equal sign. It kind of means y is almost similar to, or it's approximately equal to this mx plus b. So I'm going to hit y. Now, I also want that y to be representative of the list of y's that I just entered into the calculator. And I can see that it says y1. So I'm actually going to type y, and then I'm just going to hit the number 1, and it automatically says y1. And it even tells me that there's 12 elements in that list, and I know that to be true. Great. So now I'm going to use my shift in the upper left corner, and I have that approximate sign. I'm going to hit M, and then I'm going to hit X, and I'm also want that X values to be my X value, so I'm going to hit X1 plus B. And look at that. Automatically, all the information that I need appears right underneath my equation. All right, well, let's take a look at how we're going to translate that into the answer to the first part of this question. So I'm going to bring this back up here. All right, and I'm going to be really careful to write down all the important information. So first I'm going to kind of write, well, what is my basic form of a line? Well, it's y is equal to mx plus b, right? My slope-intercept form. And it said to round off all my values to the nearest hundredth. I always remember that 100 has 2 zeros in it. So 100th means to round off to 2 values after my decimal point. So if I go back here and I have to write down what I need my m and my b to finish this line. So I'm going to write my m equals, and I'm going to go to my calculator, and my m rounded off to the nearest hundredth is going to be negative 0.96. So I'm going to put negative 0.96. Now I need my b. So I'm going to put b is equal to, and again, I'm going to round it off to the nearest hundredth, and my b is going to be 64.7. Now I need that 3 because that's 2 places, but I look 1 place to the right, and it's an 8. That's a big number. So that means I'm going to add 1 to my 3. So it's going to be 64.74. 64.74 to the nearest hundredth. And now to finalize my answer, I'm going to substitute them in. And I'm going to get y is equal to negative 0.96x plus 64.74. And that right there is my linear regression. Now there's another part to this question. The other part to this question says, once we have that done, state the value of our correlation coefficient, also to the nearest hundredth, and then explain what it means in the context of this problem. Well, if you've forgotten, the correlation coefficient is your value of R. All right, so I'm going to go back to my calculator, and I'm going to look at my R, not the R squared. Don't get confused between the R squared and the R. We want our R, and I see that that is going to be rounded off to the nearest hundredth, negative 0.98. There's a 4 next to that 8. That's a small number, so it's going to stay negative 0.98. Equal to negative 0.98. And that is my correlation coefficient. Now let's explain what that means. Well, as our correlation coefficients get closer to the number 1, they become super, super strong indicators that this data, this information is correct, or there is a correlation. So negative 0.098 means that the number is still close to negative 1, which also means it's super strong, but this means that it's a negative correlation between the age of a driver and the percentage of accidents caused by speeding. So I'm going to write exactly that using those words in my explanation. So negative 0.098 means there is a strong, because it's close to 1, negative, because it's negative correlation between someone's age, just repeating what it's showing me, and the percentage of accidents caused by speeding. There you have it. I think that would qualify as 4 solid points here. Notice I had my y equals mx plus b with get my values of M and my values of B rounded correctly, substitute them into the equation, get my correlation coefficient, my R, and then give a good explanation in the context of this problem. I hope you found this lesson useful, and don't forget to subscribe to Mr. Frank's YouTube channel.